In this video, we will cover a review of explorations in mathematics. This review has 60 questions, and what I'll basically do is go through half of them, where I'll go ahead and do the first one of each problem type. Of course, I would encourage you then to pause the video and try the second one and use the answer key at the end of the review to check your answer. So here we go. We're going to go ahead and look back to our systems of numeration. It was chapter 4. So we first were asked to learn how to write an Egyptian numeral as a Hindu-Arabic numeral. And of course, the Hindu-Arabic numeral is essentially the descendant of the numerals we use today. So we have this chart provided, and on the exam, the chart will be provided. So you just have to remember that it is an additive system. That is to say, if you see the coiled rope right here, you'll have two of them. So this is going to be 200. And then the 1, 2, 3 heel bones are going to give you 10 each. So it's going to be 30. And then the 2 staves are going to be 1 each. So this is ultimately going to be 232. Again, just to reiterate, I would encourage you to pause the video as I go through do the first example to try the other one. The second one's usually a little bit harder, but it'll force you to really make sure you understand what's going on. So now we're asked to write the Hindu-Arabic numeral as a Roman numeral. So again, this chart is provided on the exam. So if we break this up, in the case of number 3, we have 24. So again, it's an additive system, so we'll want to break this up as 20 plus 4. But the thing to remember, especially when it comes to the 4, that you're almost to 5. So let's go ahead and write it like this. So remember that you're going to have 20, which is going to be xx. We'll write that on the next step. And then the 5 is, let's try this again. That's 4, and then 4 is basically 5 minus 1. So when you're almost to the next numeral, you do need to remember to shoot past it and then go back. So this is going to be xx, and then we add to that the not vi, but iv, because remember when you go up from a smaller number to a larger, it is going to be a subtraction right there. So the answer here is just going to be xxiv. All right. In the case of number 5, we're asked to convert the given numeral to a numeral in base 10. And again, now that we're settling into the review, one other thing that I want to remind you, or I just want to go ahead and say, is that if a problem is not on this review, it will not appear on the final. Okay, so with that being said, let's go ahead and convert a given numeral to a numeral in base 10. So remember, let me zoom in here, it makes it a little bit easier to see. We have to essentially do a pairing. The base here is 3, so what we need to do is with the 2, pair that with 3 to the 0, and then we would pair 1 with 3 to the 1. And if we had another number, let's say 2, we would pair that with 3 squared, and you would just increase in place value where the value here is whatever powers of the base are. So first, we're going to do the 1 times 3 to the 1, which is 3. And then we'll add to that 2, which again, just to iterate, this 2 is coming from right here, and then this 1 is going right there. So then we multiply that by 3 to the 0, and remember that 3 to the 0, that is simply equal to 1. So now we simplify this. This is going to be 3 plus 2, or ultimately just 5, when we consider it as a numeral in base 10. All right, in the case of number 7, we're asked to convert the number 63 to a numeral in the base indicated. So remember that what we're going to do is if we're going to base 2, we need to consider powers of 2. So 2 to the 0 is 1. Let me make my pen a little bit thicker again. So 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. And you're going to keep doing this until we exceed the number we're converting from. So we're going to have 2 cubed, which is 8. We're going to have 2 to the 4th, which is going to be 16. 2 to the 5th is going to be 32. 2 to the 6th is going to be 64, and we've exceeded 63, so we don't need that one actually. So you start with the largest number, and you're just going to go ahead and do some division. We will need to do long division in order to make sure we have the quotient and remainder. So we're going to start with the 32, and that is going to see how many times that divides into 63. Well, it goes in once. 1 times 32 gives you 32. Take away, and you end up with still a remainder of 31. So that's done, and now we just go to, we move down. So 16, see how many times that goes into 31. Well, it goes in once. 1 times 16 is 16. Subtract, and we have 15. Okay, going down to 8, and 8, when you divide that into 15, and again, the number is just kind of translating up. That goes in once. Let me zoom in here. This is going to then have a remainder of 7. Then we do 4 divided by 7. 4 goes in once. 1 times 4 is going to be 4. Subtract, we have 3, and we just keep going until we do all of the numbers. So 2 goes into 3 one time. 1 times 2 is going to give you a remainder of 1. And 1 goes into 1 one time. And again, because you're always dividing by 1 at the end, you'll eventually have no remainder. So as the number across the top is going to, the quotients is simply going to be the conversion. That is to say, 63 in base 10 is 111 base 2. Now we're asked to add in the indicated base. So in the number 9, we're given 2 base 4 numerals, 1 to 1 base 4, and 3 to 2 base 4. When we add them, when you add in base 4, it'll continue to be a base 4, so you could kind of just write that 4 down if you want. And then you just add down the columns. 1 plus 2 is going to be 3. And remember that in base 4, the numerals that we have access to are 0, 1, 2, and also 3. In a base 4 system, you have 4 numerals. 3 has not exceeded the base, so we're good to go there. Now when we add down the second column, 2 plus 2 is 4. But again, 4 we don't have access to in a base 4 number system. So when you think about counting, if you were to go ahead and continue counting 0, 1, 2, 3, you would reset and you would increase the place value. So 4 is actually 1, 0. So that is to say, we are at the base, so we'll go ahead and put a 0 here, but then we have to carry a 1. 1 plus 1 plus 3, well, that's 5. 5 is one number over the base, so we'll put a 1 here, and we'll carry a 1. You'll never carry more than a 1. So bring down that 1, and we have our answers 1103 base 4. All right, we don't need to learn about, or we don't need to review subtracting in different bases since it's not on the final review. Let's go ahead and look at lattice multiplication now. So lattice multiplication, you're going to go ahead and set up a lattice. So we're going to need a 3 by 2 lattice. Let's go ahead and make that square. So the autocorrect in square. So we'll need 3 columns and then 2 rows. So 125 goes across the top and 23 across down the side. Then to complete the lattice, we have to have a diagonal in each one of these little windows. Okay, now we just do some multiplication. 1 times 2 is going to give you a 2, and because it's technically 0, 2 if you want to use both parts of the lattice. So I'd put a 2 here, and then a 0 would go there. So just moving clockwise now, 2 times 2 is going to give us 4, so there's a 0 here. 5 times 2 is going to give you a 10, so that goes there. This is 0, 3. 2 times 3 is 6. and 5 times 3 is 15. Then you just simply add down the diagonals. So 5 here. Then you'll go ahead and add those. So 0 plus 1 plus 6 is 7. And then we'll add down those. 1 plus 4 plus 0 plus 3 is going to give you 8. And then we have a 2 right there. So your answer right here is just that direction. So the product is going to be 2875. And again, as you go through these, remember, you could always verify things. So if you did 125 times 23, you'd end up getting that answer right there. All right, so that actually completes our review of Chapter 4. Let's go ahead and look at some financial mathematics. That is to say, Chapter 10, where we started our look in Chapter 10 looking at percentages. We're asked to round to 1 decimal place. And remember that you could always set these up using essentially the idea that a part divided by a whole is going to be equal to a percent as a decimal. So 12%, well, we're given the percent part, so that's going to be, so there's our percent, and 12% of what number, of 40 is what number? So this of is an indicator for a whole in these basic questions. Of course, if you have a more complicated word problem, you do need to use context. And then the what, this is the part. This is what we're missing. So if you go ahead and set up using this, essentially this definition of what a decimal is, or what a percent is, part will just be our x, our unknown. We're going to divide that by a whole, which is 40, and we'll set that equal to 12%, which is as a decimal 0.12. And again, you might not have needed to worry about that setup, but once you have that, you could cross multiply. So x is equal to 0.12 times 40. And again, you are welcome to use a calculator on the test. So it is simply going to be 4.8. I'll just go ahead and slide that off to the side since we might need that later. All right. So 14 is a similar setup. And in 15, we change it up and we're asked about the percent. So what percent, that's the unknown, of the whole is 24. So 24 divided by 96, that is going to, of course, be some unknown. We'll just call it x. That is the percent as a decimal. So 24 divided by 96 is going to be 0.25. So x here is 0.25, but remember that you do need to convert this to a percent to go ahead and answer the question completely. All right. Number 17, we're asked to find the percent change. If necessary, round the percentage to 1 decimal place. The formula here is provided. So the percent change is going to be equal to the new amount minus the old amount divided all. And again, emphasize that this needs to be grouped. So do that subtraction before you divide by, again, the old amount. Of course, we need to multiply that by 100% to get the correct form. So the regular price of a Philips Color TV is $539.62. So this right here is, well, let's go and read the whole problem. So during a sale, Hill TV is selling the TV for $439, and we're asked to determine the percent change in the price of the TV. So again, the word percent change here is an indicator that we're going to need to use this formula. And the PC, I'll just do percent change for short. So let's go ahead and actually label everything. Our old, before the sale, was going to be that $539.62. The new amount is going to be $439. And this is what's going on in the sale. So And it's gone down, so you expect our answer to be negative. But remember, with percent change, you just really, well, I'll talk about that when I get there. So the new amount is $439. We subtract $539.62, and we divide that by $539.62, and then we multiply that by 100 to get our answer as a percent. So let's go ahead and clear this. So 439 minus 539 and 62 cents hit equal to here. That's the important thing. That top is grouped, so you do need to hit equal before you divide again by 539 and 62 cents. And then if you multiply that by 100, it gives you this answer of negative 18 point, and it wants one decimal place, so we'll just do 6%. So we have found the percent change. If it asks for the percent decrease, we would just simply say it was an 18.6% decrease. But since it just said percent change, we just leave that answer as negative. We now move on to working with interest. So number 19, we have we're going to be asked to find the simple interest right here. So read the directions. That gives you some indication about what formula we'll need to use. So I is equal to P times R times T. So that is going to be our simple interest formula, where P is the principal, R is the rate, and T is the time. And again, remember that the rate and the time need to be in the same unit. So in the case of number 19, the Small Business Administration Loan. So Joshua uses the Small Business Administration Loan, or SBA, to obtain help to expand his vending machine business. He borrows $25,000. So that $25,000 where he starts is the principal for 2 years. So there's our time, with a simple interest rate of 1.5%. And again, that maybe I should remind us that the rate, you have to go ahead and move over 2 decimal places, because again, you multiply it in as a decimal. And we're asked for the repayment amount. So be careful here. We're not just asked for the interest, we're asked how much we to pay. So repaying is simply going to be the principal, how much borrowed, plus the interest. So the interest is going to be, and if it's not specified, we could assume that the rate is in the same time unit. I believe it would be it would be years here. So we assume an annual rate. So principal is $25,000. We multiply that by 0.015. Careful with that 1% that you don't accidentally convert that to 15 or 0.15. And then you multiply that by 2. So let's go ahead and get our calculator out here again. 25,000 times 0.015 times 2 is going to be $750. But that again is not the answer. That's just the interest. So the repayment here is going to be the principal, which is the $25,000, along with the cost to borrow, which was $750. So our answer here is $25,750 as the repayment amount. We move now on to compound interest. So the formula is a little bit more complicated. Remember to use this formula. The operations that you do is you'll go ahead and do this division first. So that'll be the first thing. Then you'll add 1. You'll raise it to the n times t. So you're going to do the exponentiation. And then you'll multiply it by the principal. So I always like to do that n times t ahead of time, just because these are usually nice whole numbers. Okay, so let's see, we're asked, use the compound interest to compute the total amount accumulated. So we are asked to find A, nothing tricky like above. Just go ahead and plug everything in, make sure you know how to use it. So $4,000 is the initial investment or loan, depending on whether you're having your money work for you or against you. It's a 2-year loan and is 0.06%, or 6% or 0.06 is the rate. So your rate, make sure again that you convert. And is compounded semi-annually. That's to say is compounded twice a year. So the accumulated amount, let's go ahead and, so A is equal to 4,000. And we're going to multiply that 1 plus 0.06 divided by n, which is 2. And you raise that to the n times t. So that's going to be 2 times 2, or 4. So again, you're going to start by doing the 0.06, divide that by 2, hit equal to, add 1, hit equal to, and then make sure you know how to use your calculator. So my exponentiation button is this x to the n, and then I'll hit 4, hit equal to, and I'll multiply that by 4,000. So 4, there it goes. So the answer here is going to be $4,502.04. And again, this, just do a quick mental check. This makes sense because he started with 4,000 and we started with 4,000, and then this part right here is the compounding part. So should be a little bit more than 4,000, especially since it was such a short term, namely 2 years. All right, so that is when we're dealing with smaller term loans. So if you were to go ahead and work with something a little bit longer term, you might have some sort of APR, an installment plan to consider, or a mortgage. What we're doing here is something typically maybe associated with cars and the number of payments. So now Brenda is a beautician who is opening her own salon. She needs this $8,500 to purchase furniture and equipment, and finances the entire purchase on a 48 fixed installment loan, 48-month fixed installment. So that's going to, that 40, let's go ahead and change to a highlighter. So we're going to be looking at this row, and so that because of the 48, and she has a fixed installment loan with an APR of 4%. So it's going to just be this first column. So what we have right here is the finance charge. The finance charge per 100 so that is going to, let's go ahead and box this in. This is the finance charge per 100. So we broke this down in steps. The first step, we basically go ahead and use the table, and we find that we get $8.38 per $100 bill. And again, that's indicated by the table right there. The second step, what we need to go ahead and do is determine how many, let's just write this. So the second step is we're going to take and determine how many 100 she has to finance. So she started with a $8,500 loan. And if you just cancel out, divide that by 100, you'll find that she finances 85 $100 bills. So the answer, or the third step, the finance charge, which I'll just say FC for short, is just the product between 8.38 and 85. So 8.38 times 85 will be $712.30. So again, this is just the finance charge right here. This is essentially, you can think about it as the interest in a simple view. We don't need to figure out the monthly payment or the total amount to repay. So just make sure we're comfortable with what we're asked. I think the problems initially, we had some more work to do, but here we just want the finance charge. So that actually completes chapter 10. So now let's go on to chapter 13, where we looked at graph theory. In the first problem, we're asked to create a graph with two odd vertices. And again, there are several answers to each of these problems. And maybe the simplest one here is just to have two vertices, let's call them A and B, and have one edge that connects them. And again, just remember that the degree of each vertex is how many edges come or go into it. So this one is just the one edge. So A has a degree of 1. B has a degree of 1 as well. So we have two odd vertices. And again, that's probably the simplest one. There are various other ones, so I would encourage you to think about that. So this is really a graph with exactly two odd vertices, and there's a little bit of ambiguity here. If you wanted one with two odd vertices, so let's say we have A and B, so we want that one to, so let's see what we can do here. So let's go ahead and put a C here, and let's go ahead and put another vertex D here. Well, let's see if this works. A is now a vertex of degree 2. B has a degree 2 because of the two edges. But notice that C and D both have degree 1. So this is one where there's two odd vertices and two even vertices. So again, just to review a little bit about the basic properties would be a good idea. So I actually answered 26. So see if you could find something different. Didn't even realize I did that. All right. In the case of 27, we're asked to determine an Euler path that begins and ends at vertex E. So if you recall, when we learned about Euler paths, we essentially looked at the degree of each vertex. So E has a degree of 3, F has a degree of 3, G has a degree of 2, C has 1, 2, 3, has a degree of 4, A has a degree of 2, B a degree of 4, and D a degree of 2. So if you recall that in order to have an Euler path, you could have at most two odd vertices, or let's try that again. If you have exactly two odd vertices, you can find an Euler path. If you had no odd vertices, you could find a Euler circuit, or they were all even. And if you had more than that, you wouldn't be able to find either. So again, we're asked to find an Euler path, and we're fine starting at E. So just kind of remember to finish off each portion of the graph at before you move on, and don't accidentally block yourself out of a certain area. So we'll go E to D, then let's go up to B. And remember, we have to use all of the edges for Euler. I don't know why I didn't say that first. So Euler is for edges. Okay, so let's go ahead and now go up to A. Let's go down to C. So we can't repeat any edges, so that's good. We finished up the top. Let's go over to back to B. And again, Euler is about edges, so it is okay that we are repeating the vertex B there. Then let's go back down to E. Then let's go over to F, because that's our only option. Then let's go up to C. We're not done yet. Even though we're at the other odd edge, we have to get these last few or the other odd vertex. We have to get these other edges. So we'll go up to C. Then we'll go back down to G. And then finally, we finish at the other odd vertex, which is F. So that completes an Euler path. And again, an Euler path, every edge has to be used exactly once. It's okay if we repeat vertices. The Hamilton is where we couldn't repeat vertices. I think we have that a little later. Okay, so now we have a Euler circuit. So Euler circuit, again, just to maybe do this quickly, if you look at each of these, that's degree 2, that's degree 4, that's 2, that's 1, 2, 3, 4, that's 4, that's 2, 2, 3, 4, that's 4. All of the vertices are even degrees, so there's no odd vertices, so we're able to find an Euler circuit. It can start wherever. It tells us explicitly to start at A. So let's go ahead and do that. So I'm going to just do this one a little differently. Of course, you could just sequence them, but I'm going to start here at A. I'm going to go down to F. There's my first move. I'm going to go down to E. There's my second. I'll go over to D. There's my third. I'm going to come back here to F. This is my fourth. Let's go. If you kind of look at what I've done right here, if I go over here, we just got to be careful. Don't go back to A yet. So that'll be my fifth. Then I'm going to go down here to D. That'll be my 6th. Then up here will be my 7th, then to my 8th, and then back to A. And remember, a circuit has to start and end at this same spot. So we are good. There is my Euler circuit, which you could go ahead and just label as A to F to E to D to F to B to D to C to B and back to A. And again, starting and ending at the same vertex, we got our circuit. All right, so that's halfway done. Let's keep moving on. So determine two different Hamilton paths. So again, Hamilton, we are looking at exactly, I'll just say this. So there's each vertex appears or is used exactly once. So in the case of 31, you kind of have to be clever about where you start. Because if you start at F and you go this way, you'll realize that you'll block yourself into this corner. So let's go ahead and start at B. Go ahead and avoid F because I can see right there that this edge right here is a bridge. I don't want to cross that until I'm done. So we'll go there, then so that gets A, then we go down, that gets our second one, so that is E. We'll go over to F, that's our third movement. So notice we got all those, and it's okay that it's okay that we don't use this one, because remember that the Hamilton is about vertices. So we'll go ahead and cross over to G. So that'll be our fourth. And you have some options. You can go this way or you can go up and around. So that is pretty easy to get the two different ones. I'll just go ahead and do one. So just for some nice symmetry, we'll go ahead and go to H. There's 5, there's 6, and there's 7. So that is your Hamilton circuit. We started at B, then we went to A, then we went to E, then we went to F, we crossed the bridge to G, we went to H, then up to D, and then finally to C. So notice that none of the vertices are repeated. All right, so the case of number 33, we are asked to use the graph represents the total cost of travel between 4 locations, A, B, C, and D. And we're asked to use the nearest neighbor method to approximate the total cost of the trip. So remember that the nearest neighbor method, we do need to figure out where we're start. So we're starting and ending at A. So if we start and end at A, we're going to just look at our options. We can go to B, which is a cost of 10. We can go to D, which is a cost of 7, or down to C, which is a cost of 21. So of course, the nearest neighbor will go down to D. So we go from A to D, so A to D, and if we keep track of our cost, it's going to be 7 there. Okay, so we need to go ahead and visit all of the locations. So we don't want to go back to A, we need to either go to C with a cost of 8 or up to B with a cost of 14. Well, the nearest one would be to go over here to C. So A, D, C, and that was a cost of 8. So that adds 8 to our trip. We don't want to go back up to A yet, so we have to go to B. And that's going to give us a cost of 5. And then, of course, we do need to return home. So this is going to give us a cost of 10. If we add all of this up, we'll end up with let's go ahead and finish our circuit. So there's our circuit. So that is going to be 25 if you add all of those together. And again, this is an approximation because you're just always you're not planning ahead. You're just saying, hey, where's closest? And sometimes that could get you into trouble. Like if you ended up here and you had to go use the 21, if you ended up at C, that could have been a little bit of an expensive trip, but it is still a pretty good approximation that is easily found compared to the brute force where you try every single circuit and just try it. And that gets very big, very quick. All right. So let's go ahead. We have some more graph theory. we're asked to draw a graph that represents the given information. So we have a family tree. So remember, in a tree, every single edge is a bridge. And a family tree is a pretty intuitive tree because if you start with Joe up here at the top, Joe has 2 children, Alan and Rosemary. So just kind of keeping this hierarchy. Alan has 3 children. So Alan will have 3, and we call these leaves when we're talking about a tree. But again, we didn't go too deep into this, but just those 3 children were Christopher, Donetta, and Kay. And again, as I'm doing my labeling, just making sure that I don't reuse any variables. And Rosemary actually has no children, so we're done here. And if we looked at this and that were to disappear, notice it would disconnect the graph. And that same thing could be said. If AD disappeared, then we would have a disconnected graph. So that is a quick look at a tree. That completes our review of graph theory. All right. So we then looked at voting theory. And voting theory structured this part of the review a little bit differently because basically all of 37 through 40 are grouped with this chart. So I'll go ahead and do all of these, but then I'll leave you the next 4 because that will be dealing similar problems, just a different preference table. All right, so the members of the Student Council at Ohio State University are planning to go out for dinner following an upcoming meeting. This is making me hungry. The restaurant choices are Chipotle, Jimmy John's, Domino's, or Burger King, and the members rank their choices according to the preference table. So remember, the way this preference table works is that 5 members on the committee ranked them in this order, 2 ranked them in this order, and so on. So to figure out how many voted, you just have to count the number of ballots, and that's just the top row. So it's going to be 5 plus 2 plus 1 plus 2. So 10 people are on the student council. For 38, we're asked to use the plurality method to determine which one is chosen. And this little italics reminds us the plurality method. We just literally look at the top row here. So each voter votes for one candidate, so we would just ignore their ranking and just look at their top row. So that is to say, let's see, how many votes for Chipotle? It would just be the 5 from the top. Then we have Domino's. Domino's gets these 2 votes and this 1 vote, so that's going to be 3. Then Burger King, 2 people voted for Burger King, and if you look, Jimmy John's, no one ranked as their top choice. So we could also put this off to the side that Jimmy John's was 0. So the winner here is just the one with the most votes. So here, Chipotle wins. Looks like they're going out to get some Mexican. All right, so the second method is the board account method. So let me go ahead and clean up my table here. And there's a little bit of italics there. And again, the fact that it's provided here means it'll be provided on the test as well. So what we'll see for the 4th place votes is that they get 1 point per vote here. So Jimmy John's gets the 5 points right here because it was voted for by 5 people. It was ranked 4th. So Jimmy John's gets 5s. And then you just increase. So the people who were ranked 3rd get 2 points per vote. Then those that were ranked 2nd will get 3 points per vote. And we start at the bottom because the last place will get 1. And so if there were five options, then you would actually have 1, 2, 3, 4, 5. But here, because there were 4 options, anyone ranked top gets 4 points per vote. So you essentially just count out multiples. Jimmy John gets 5 points, Burger King gets 10, just based off of the top number. Then what was this one? Domino's gets 20. And just finishing the table, this is 2, 4, 6, 8. 1, 2, 3, 4. 2, 4, 6, 8. So a little bit of adding to do right here. But you will then have your totals. So let's go ahead and add these together. So we'll just kind of use that first column. So C got 20 points. Let's kind of line it up here. So C got 20 points. Domino's got 15. Burger King got 10. Jimmy John's got 5. In the second column, let's see, Chipotle got 2 coming from right here. Jimmy John's got 4. So we'll go ahead and put +4. Burger King got 6 and Domino's got 8. Third column, let's see, Chipotle got 2. Domino's got the top 4. Burger King got 3. And Jimmy John's got 1. And then the last column, Burger King got the 8. Chipotle got 6. Jimmy John's got 4. And Domino's got 2. So let's zoom in and add. So if we added up that first row, we get, let's see, that's going to be 30. Domino's ended up with C. That's going to be 14 and 15, so this would be 29. Burger King is going to be 16, 19, and 8 is going to be 27. And Jimmy John's is going to be 5 plus 4 is 9, plus 5 is 14. So here, again, Chipotle wins again. All right. And now we're going to look at the plurality method. More specifically, I misread that, plurality with elimination. So again, you have to kind of think about, okay, what is the majority? So if we remember, we had a total of 10 votes. So a majority here is greater than half. So more than 10 divided by 2. So it's going to be more than 5. So a majority is more strict than 5. All right, so essentially you'll just go ahead and do the same thing you did with plurality, and if you don't, until someone has more than 5 votes. So we really could start with the same thing we did up at 38 for our first election. So let me zoom in here just to make my writing better, and I'll zoom back out. So our first election, just looking at the top row, we can see that Chipotle had 5, Domino's had 3, Burger King has 2, and Jimmy John's has 0. There's no majority, so what you do is eliminate the lowest one, Jimmy John's. Now you go ahead and hold a second election. And during the second election, what you'll go ahead and do is just cross out Jimmy John's. Now, so again, let me just zoom back in this table and clean it up just so you can see it. So wherever there was a Jimmy John's, you would have crossed it out. So let's go ahead and do so. If we eliminate these, it doesn't really change that top row. So the second election is actually the same as the first, where 5 for Chipotle, 3 for Domino's, and 2 for Burger King. So again, what you'll have to do is you'll have to eliminate someone because there's no majority. So we'll go ahead and eliminate Burger King. So let's go back up to the chart now, and I'll cross those out. So Burger King, Burger King, Burger King, Burger King. So what you'll see now is Chipotle could kind of moves up, and these two will also go to Chipotle. So, man, everyone wants some Chipotle. So on our third election, just zooming in to right a little bit, our third election, what we'll go ahead and do is now have Chipotle with the 5 originally and the 2 because B, our Burger King, was eliminated, and Domino's only has 3. So now that Chipotle has 7, a majority, which because it's more than 5, we could once again say that Chipotle wins. Okay. The fact that pairwise elimination is not, or pairwise comparison is not here, means I wouldn't worry about studying that for the final, unless if you just want to review the whole course for your own academic growth and enjoyment. So 41 through 44 are very similar to what we just did. So let's go ahead and now look at a little bit more with the let's see what we're doing here. Voting theory. So voting theory, we're going to look at the apportionment method. So a post office in Riverside has 3 regions to distribute mail and 10 new mail trucks. The trucks are to be apportioned on the number of houses in each region as shown in the table below. So you can see right here that there are 5292 houses in region A, 1428 in B, and 1980 in C, and there's a total of 6,000 houses. So we have 10 mail trucks we have to apportion. So the total population divided by the number of items to be apportioned is the standard divisor. So the standard divisor is going to be 6,000 divided by the 10. So it's just going to be 600. So this right here is our standard divisor. Now we use that standard divisor to go ahead and find the Hamilton's apportionment. So remember what you do is for each region, you're going to find the standard quota. So again, it's not provided here, so you'll need to make sure you know how to do it. But let's go ahead and find the standard quota for each region. So just, I'll kind of imagine these go down or like a column like so. So the standard quota, what we'll do is we'll take the 2592, how many people in that region, and now that we have a divisor divides. So we'll divide it by 600. So that right there is going to give us a, let's see, 2592, and we'll divide that by 600, and that's going to give me a 4.32. So let's go ahead and just do that for the rest of the columns. So I'm going to go ahead and erase that just so we have room for later. So that's 4.32. For region B, it's 1428 divided by 600. So that's going to be 2.38. And then we have 1980 divided by 600 is going to be 3.30. So then we'll take the lower quota, and that is to say we'll round them all down. So we have 4, we have 2, and we have 3. So right now we have allocated 9. So if I add these up together right now, we have 4 plus 2 plus 3. So right now we have 9 allocated so far. So where does that extra 1 go? Because we had 10 in total, and we have 9 allocated. And for Hamilton, he said, well, whoever has the largest fractional parts. So region B has 0.38. This is 0.32, and this is 0.3. Well, the largest fractional part gets the extra. So there's only 1 extra, so it'd be 38. If there were 2 extras, then it would go to A and B. But Hamilton's apportionment is going to be 4 here, 3 there, and 3 there. So again, if you were asked for a How many are apportioned for region B? You would say 3, or how many allocated to region B? Same principle for the other ones. So that is a review of Hamilton's method. 47 and 48 are very similar. The fact that Jefferson's method is not on the review, I would encourage you not to stress about that one unless if you just want to review it for your own enlightenment. Now, lastly, we ended the semester with algebra, or at least this semester. Sometimes it's in the middle, but it's in the end here. So let's go ahead and just review a couple basic algebra problems. In the first one, we're asked to evaluate the expression for the given variable. So we're given that x is equal to -2, so I'll just go ahead and replace x with -2. So we have a minus a -2 squared minus 5. Be careful with order of operations, because the minus comes down and -2 squared is going to be a positive 4, and the -5 comes down. -4 minus 5 is going to be a -9. 50 is a little bit more complicated, and again, I've actually provided videos for all of Chapter 6, so if you need a little more review, feel free to go back and review those. Okay, 51 and 52 were asked to determine whether the given value is a solution. So we have an equation now because of the equal to sign, and we'll just plug 3 into wherever the x's are and see if both sides of the equation match. So 4, the number that we're to plug in for x, 4 times 3 now, plus 5, is that equal to 17? Well, 12 plus 5 is equal to 17? Yes. So we can say that, that 3 is a solution. 53, we're asked to solve for the given variable. This one's fairly straightforward. We just have to isolate the variable t. And we do that by doing our order of operations backwards. So we start by subtracting 8 from both sides. And that leaves me with a 4t is equal to -20. Then I'll divide both sides by 4. And then I find that t is equal to -5. So there's our answer. 54, we have the distribution property to worry about first, but after that, it's pretty similar. 55, well, this one was a little bit trickier because we have the fractions, but the goal here is just to look at the least common multiple or the least common denominator. So if we think about 5 and 4, if you were to just count multiples, you'll see that 20 is the first multiple that occurs for both of the denominators. And again, 56 is a little bit more complicated because you have 3 denominators, but again, just go ahead and just find the least common multiple of the denominator, sometimes called the LCD, or the least common denominator. And what you'll do is multiply everything by 20. Now you can distribute, but I find it easier just to say, okay, you can just go ahead and divide because that's just being multiplied against the numerator. So you just divide that, and it's going to be a 20 divided by 5 is 4, and then we have x plus 2. And then we have 20 divided by 4, it's going to be 5. And again, multiplication, you can multiply in any order, so I'll just go ahead and rewrite that there. Now, I'm going to go over here to the side. So when you distribute the 4, I'll just go down first. So this is going to be 4x plus 8. And then we distribute the 5. So this is going to be 5x plus 5. And I'll go ahead and move this over actually a little bit. So we'll then go ahead and combine our like terms. You have some flexibility here. I'm going to go ahead and subtract 4x from both sides. If I do that, I'll have 8 is equal to x plus 5. And then I'll subtract 5 from both sides. And I'll have 3 is equal to x, or x is equal to 3. So there's our answer. We're now asked to graph the solution set of the inequality where x is a real number. So we just have to solve for x first. So in the case of 57, if I divide both sides by -5, I'll get x and then I'll have a -2. But remember, when you divide by a negative, you flip the inequality. So x is greater than 2. On a number line, if you were to just put minus 2, think about a number that's greater than minus 2. So let's say minus 3. Well, you'll go ahead and just put an open dot because it is not equal to, and then you'll shade towards the number that is greater than 2, negative 2. In the case of 59, it's a compound inequality, so it's already x is already isolated. So here I'll need to put on my number line negative 1 and 3. And negative 1 is less than or equal to x. So because of the equal to part, I'm going to put a closed dot. And, well, that means x is greater than negative 1. So I'll be looking at like the number 0. And x is also less than 3, so it has to be less than 3. So it'll be this little region in between those two numbers I placed. And then an open dot at 3 because there's no equal to here. 60 is pretty similar. You just have to add 1 to all parts. And again, because we're not dividing or multiplying by negative, nothing changes with the inequalities. So that is a review. I would encourage you again to redo this until you're confident with all of the different problem types shown here. I hope you've enjoyed this course. We've covered a lot of ground and explored some interesting topics. So good luck preparing for the final and have a great future.